The quickest way to sharpen your mind is to read more analyses of underlying principles. Over the next 2.5 years, I will guide you through a systematic breakdown of the principles behind all manner of things. Today, we'll discuss why China's Three Gorges Dam is more impressive than America's Hoover Dam. You might think that the world's most impressive dam is the Hoover Dam, but when you see the scale of the Three Gorges Dam, you'll realize that Hoover is merely a pioneer, whilst the Three Gorges is the true giant that commands the river. Let's first look at the Hoover Dam. It faces the Colorado River, which boasts immense water volume and powerful currents. So, rather than building the dam first, the engineers diverted the river. This wasn't a simple diversion. It involved completely isolating the construction zone. They blasted 4 massive diversion tunnels through the solid rock on both banks, each with a diameter of nearly 20 meters. Blasting, excavation, and shoring advanced simultaneously. Millions of cubic meters of rock were cleared away. Immediately afterwards, using rubble and concrete, a temporary cofferdam was built in the riverbed, raising the water level, before forcing the entire river to flow through the tunnels. The once raging riverbed was hollowed out in a short space of time. Only then was a truly dry construction space created. Next came the dam itself. The living booted dam did not opt for a single pour construction, as this would inevitably have caused it to crack. During the setting process, concrete releases enormous amounts of hydration heat. If poured as a single mass, the internal temperature could reach several dozen degrees or even higher. With the exterior cold and the interior hot, cracking would occur immediately. The engineers chose to divide the entire dam into thousands of independent pouring sections, much like building with blocks, stacking them one by one. Gaps were left between each block to allow for thermal expansion and contraction. But leaving gaps alone was not enough. They embedded hundreds of kilometers of cooling pipes within the concrete, continuously circulating ice-cold water to forcibly lower the internal temperature. A colossal structure that would naturally take centuries to cool was compressed into a process completed within a few years. Further down lies the foundation. Before construction began, all loose rock was cleared away, excavating down to the hard bedrock. All gaps were then sealed with grout to ensure the dam sat on a stable, watertight foundation. Even so, the pressure of the water remained formidable. So, ingenious engineers designed a seepage and pressure relief system to divert water seeping into the dam and foundations, releasing buoyancy and preventing the entire dam from being lifted. Finally came power generation. When water enters the intake tower from above, it surges through massive steel penstocks towards the turbines, driving the generator units to rotate and converting gravitational potential energy into electrical energy. Of course, in the event of a flood, excess water is diverted directly past the dam via the spillway, and can even make use of the original diversion tunnel to divert the flood peak. Now let us consider the world's largest Three Gorges Dam. The challenge it faces is how to maintain long-term, stable control over everything on a river of world-class complexity. The Yangtze is not the Colorado River. It has a greater volume of water and a higher silt content. Its floods are more violent and its fluctuations more complex. And it underpins the production systems of hundreds of millions of people. To construct the Three Gorges Dam, the first step was also diversion, but on a completely different scale. Construction employed phase diversion. First for the right bank, then for the left bank, dividing the entire Yangtze River in stages. This was not simply a matter of digging a few tunnels, but of constructing a colossal diversion system, allowing the main navigation channel and the construction zone to switch dynamically between phases. Next comes the concrete. The volume of concrete used in the Three Gorges Dam reaches 27.94 million cubic meters, several times that of the Hoover Dam. With such a massive volume, if the temperature is not properly controlled, the resulting stresses could tear the dam apart. Therefore, the aggregate is cooled before use. During concrete pouring, the temperature is strictly regulated, and the interior is also filled with cooling pipes to continuously dissipate heat. At the same time, by pouring in layers and sections, the stresses are dispersed across every individual unit. It was not only necessary to cool it down gradually, but also to prevent it from heating up in the first place. However, the most dangerous aspect of the Three Gorges Dam was not the construction phase, but flood control during operation. Flood peaks on the Yangtze River are not linear, but are characterized by significant uncertainty. A single misjudgment would not result in a simple, manageable situation, but could lead to a catastrophic impact. Consequently, a multi-tiered, multi-level flood discharge system was designed. Surface outlets handle rapid discharge at high water levels, while deep outlets manage pressure at intermediate levels. The bottom outlets are specifically designed to handle sediment, particularly the issue of silt. The Yangtze River has an extremely high sediment load. If not managed properly, it will accumulate in the reservoir, directly reducing its storage capacity, and even affecting power generation. Through sediment flushing via the bottom outlets and water level regulation, the Three Gorges Dam ensures that sediment is carried away by high-velocity currents, rather than being deposited. Turning to power generation, The number of generating units at the Three Gorges Dam, along with the individual unit capacity and total installed capacity, have all reached world-class levels. Water cascades down from the upstream, and, through the giant hydroturbine units, is converted into a stable and continuous output of electricity that underpins a national-level power grid, rather than providing regional power. But it cannot merely generate electricity. It must ensure navigation. Following the completion of the Wufu Dam, the river's navigational value was effectively severed. Yet the Three Gorges Dam cannot be severed. The Yangtze River is one of China's most important waterways. 10,000-ton vessels must be able to pass through. Therefore, within the Three Gorges Dam, a system of water lifts has been constructed. One type is a 5-stage lock system, which raises vessels section by section, with a total drop exceeding 100 meters. The other is a vertical ship lift, which can lift the entire vessel as a single unit, offering greater efficiency. At this point, if you look back at the differences between the two, it becomes very clear. The Wufu Dam is a world-class engineering feat. It addresses the question of how to build a dam with the utmost safety, whereas the Three Gorges Dam is a national-level system. It addresses the challenge of, over a timescale of several decades, simultaneously and stably, managing flood control, power generation, navigation, sediment management, and water resources. Do you understand now?